In this part, we're going to take a look at graphs of lines, how we can do that from a table of values first, and then how we can also do that by taking the equation and changing it so it's easier to use. So let's talk about tables first. We need to find points that are on the line. How do we do that? Well, first of all, make sure your equation has been solved for y. Now, again, sometimes they'll give it to you in the form of, say, y equals 2/3 x plus 7, where y is on one side of the equation all by itself. That's exactly what they're talking about here. Other times, you'll be given things like 3x minus 7y is equal to 12. That's also the equation of a line, but that form, we're going to do something to that. Step 2, choose 3 values to make your table. You get to choose. Pick what's easiest to you. There is no easier number to substitute than 0. Maybe we want to substitute 1. Maybe we want to substitute 2. I would strongly suggest pick a negative each time. We not only want to know what's happening with the positive part of the x, but we also want to know what's happening to the left, the negative part of the x. And then for the next part, you're going to substitute those x values and solve for y. So in this case, now careful, y equals negative x minus 3. Say we put in 0 in place of x. So that becomes y equals negative 0 minus 3. Well, negative 0 is still 0. 0 minus 3 is negative 3. So the point 0, 3 is going to be on this line. Pick another value for x. Say I want to substitute 1. Y equals negative 1 minus 3. Well, negative 1 minus 3 is the same thing as negative 1 plus negative 3. That's negative 4. So the point negative 1, negative 4 is on this line. And say, again, go to the left. I'm going to substitute negative 2. So y is equal to negative 2 minus 3. Well, again, the two negatives turn that positive. So this is 2 plus negative 3. That's negative 1. So we would then 0, negative 3, 1, negative 4, negative 2, negative 1, all have to be points that are on our line. Plot the 3 points in the coordinate plane. Careful, please make sure every single time you are finding 3. If you find 2 points, you're always going to get a line that goes through just 2 points. If your third point goes through the same line as those first 2, then that's how you're going to check. That's how you know that your line is going to be correct. If all 3 of them aren't on the same line, then you know you've got to go back and check something. Let's complete this table. Again, we can substitute whatever we choose. The easiest number, again, when it's in this form here, where it's solve for y, the easiest thing to do is substitute a value for x because it's already telling you what your y coordinate is. So if I take half of 0, that's still 0. 0 plus 2 is 2. So I need to plot the point 0, 2. Here, let me change color for you. Get your attention there. If the x coordinate is 0, I'm not moving left, I'm not moving right. It stays on the y-axis, but up 2 spaces. This is the point 0, 2. Now, again, I know this number in front of the x is 1/2. I'm not going to choose an odd number like 7. What happens if I put in, say, 4 in place of x? Half of 4 is 2. 2 plus 2 is 4. So I would plot the point 4, 4. Now, how do I know that's correct? How do I know if I played connect the dots, this is the correct line? Well, I substituted 4. That wasn't too bad. What happens if I substitute negative 4? Half of negative 4 is 2. Sorry, negative 2. Negative 2 plus 2. Well, look at that. That's an easy point to plot also, because I have to go to the left, negative 4, and the y coordinate is 0, so it's right there on the x-axis. Eyeballing it here, it looks like those points line up pretty well. Let's try and put a line through them. Now here's another place where OneNote frustrates me, because the shapes tool that you could use up here that looks like, oh, that would be a lot. No, it tries to snap it to a grid instead of letting you just draw the line wherever you want, and I usually have to fight with it. If you simply want to freehand this and draw the line yourself so it goes through those points, I'm not going to take off points from a quiz or a test or anything because your line wasn't straight enough. Give the coordinates of the points and we should be fine. All right, so let's do some practice here. Complete each table using the given domain. Again, domain is the set of x values, and then we have to find the corresponding y values. And again, absolutely nothing wrong here with going off to the side and doing a little bit of the work. For part A, the equation is y equals negative x plus 2. So they're suggesting I substitute negative 4 in place of x. So y is equal to negative 4 plus 2. Well, the negative of negative 4 is positive 4. Positive 4 plus 2 is 6. So I'm going to plot the point negative 4, 6. The next x is negative 2. Y equals the negative of negative 2 plus 2. Careful, those do not cancel. The negative of negative 2 is 2. 2 plus 2 is 4. Usually there is no easier number to substitute than 0. Y is equal to negative 0 plus 2. Well, that's simply 2. And for the last one here, y equals negative 4 plus 2. So negative 4 plus positive 2. Again, those have opposite signs. The difference is 2. The bigger number was negative. So it's a point for negative 2. Then we go ahead and plot those points. Those look like they're lining up pretty well. Make the connection between this new material and the last lesson there about slope. Look at what's happening here. I'm going down 2 and 2 to the right. Down 2 and 2 to the right. Down 2, well, down 4, and 4 to the right. Okay, things look pretty good there as far as that being a line. Do your best, play connect the dots. Things look pretty good. That's the graph that you should get from A. Now let's look at B. We get y is equal to negative x minus 2. Okay, so again, it's a very small difference between these equations, but it makes a big difference here as far as the coordinates are concerned. So, can I just clean this up and use some of this work? So if I have to take negative 2 minus 2, and again, I'm substituting negative 4, 2, 0, and positive 4. The negative of negative 4 is positive 4. 4 minus 2 is 2. So I'm going to plot the point negative 4, positive 2. If I substitute negative 2, oh, how many negatives can we do here? So this becomes negative 2 minus 2. That's 0. Substitute 0 in place of x. Negative 0 minus 2 is negative 2. And then putting in 4 in place of x, the negative of 4 is negative 4 minus 2. So, well, that's the same thing as negative 4 plus negative 2. They're both negative. My answer is negative. 4 plus 2 is 6. So that's the point negative 4, 6. Plot those points. Well, isn't that interesting? These points all line up nicely, so sure, we can draw a line, but it looks like each one of those points that we had there on that blue line just got moved straight down. Wonder what's up with that. So this is the line from B. I'm going to try and speed things up a little bit here. For part C, the line is y equals x divided by 2 minus 3. Now again, they're putting in the same x coordinates here. You're simply going to substitute negative 4 minus 2. Negative 4 divided by 2 is negative 2. Negative 2 minus 3 is negative 5. Substitute negative 2. Negative 2 divided by 2 is negative 1. Negative 1 minus 3 is negative 4. Substitute 0. 0 divided by 2 is still 0. 0 minus 3 is negative 3. And substitute 4. 4 divided by 2 is 2. 2 minus 3, we get negative 1. So we go ahead and plot those points and play connect the dots too. And here's our graph from C. Looks very different than our graphs there from A and B. Now let's take a look at the equation for part D. Now, this is interesting. They both have the same last number, but what you do to the x as the first step, that's different. Here I have to take negative 4 when I substitute it in place of x and multiply by 2. Negative 4 times 2 will give me negative 8. Negative 8 minus another 3 is negative 11. Substitute negative 2 times 2. That's negative 4. Negative 4 minus 3 is negative 7. Substitute 0. 2 times 0 is 0. 0 minus 3 is negative 3. Oh, look, that's the same point we had just a minute ago. And then substitute 4 in place of x. 2 times 4 is 8. 8 minus 3 is 5. So let's plot these points. Well, that first one kind of is not on the grid. So at negative 4 and negative 11, it's down below where the grid stops. But we can definitely put in -2, -7 here. 0, -3 is the same spot we had on the purple one. And then 4, 5 up here. So again, that's for graph D. Then they're asking you to compare and contrast the lines. What do you notice about the direction and the steepness of each line? How do you think the numbers in the equation affect this? Well, hopefully we can agree that for A and B, they're parallel. The slopes are both negative. They cross both the x and the y-axis at different spots. If we look at C and D, they intersect. We know that because they share that one point in common. Whereas A and B were parallel to one another, C and D are not parallel, they intersect, they have one point in common. These both have positive slopes. We could say that for the green one, D, has a slope that's much steeper. Now we need to talk about slope-intercept form. The slope-intercept form is the way of writing the equation of a line that gives us some information that's going to be more helpful than constantly having to make a chart of values and just plotting those individual points. So slope-intercept form is the form of the equation of a line that tells us two really important things. We should be able to tell what the slope of the line is just by reading the equation. And it gives us the y-coordinate of the y-intercept. Oh, by the way, in case we haven't emphasized this enough, when I use the phrase y-intercept, that means the point where the line crosses the y-axis. Because it's on the y-axis, The x coordinate is always going to be 0. It looks like y equals mx plus b. M is what we use for slope. B is, again, that y coordinate of the y-intercept. There are several things you should be able to do here. First of all, if you're given a graph, we should be able to write the equation of that line in slope-intercept form. The first thing we need to do is pick 2 points and find the slope using our slope formula. That should look familiar from last time. And then we need to find the coordinates of the y-intercept. Again, if they're giving you the graph, we should be able to figure out where that line crosses the y-axis. And it's always going to have coordinates 0 something. That something is our value there for b. But we don't necessarily need a graph. If you're told that a line goes through point A and point B, we should also be able to write the equation of that line in slope-intercept form by, again, first step is calculate the slope. But if they don't give you the graph and you can't see where it crosses the y-axis, then we're going to go back and do some substitution. Pick one of those points, doesn't matter which one. Use the slope that you just found and our y equals mx plus b. You should be able to substitute numbers for y, m, and x, and then solve for b. Once we know the value for b, then we can write the equation. Why do we even do this? Because it makes graphing so much easier. If we can figure out the y-intercept and the slope, the y-intercept is literally our starting point. It's right there on the y-axis, so it's, relatively speaking, it's a pretty easy point to plot and get right. From that y-intercept, then, we're going to use the slope as a set of directions. We can either move up or down, we can move left or right, depending upon what the slope tells us to do. We're going to use slope as a set of directions to get from that y-intercept to another point on the line. And then, yeah, again, we're back to play connect the dots. So again, m is slope. It's from French. Don't worry too much about that. B is going to be our y-intercept. For our practice here, we're going to rewrite each equation in slope-intercept form if necessary and identify the slope and the y-intercept. Let me zoom in just a little bit, make that easier. Hey, look at that. For number 1, it looks like y equals mx plus b. That's already in slope-intercept form. So our slope here is -5, and the y-intercept is at 0, 2. Again, please, each time, the y-intercept is coordinates of a point. It doesn't get much easier than this because the x-coordinate is always 0. Don't just put down 2. Write it as coordinates of a point. Show that you understand that this represents a location on our graph. Here are the coordinates of that point. For number 2, well, hold on. That doesn't look like much like y equals mx plus b. There's no x at all. In other words, we have 0x. So we could take that equation y equals 8 and rewrite it so it looks like y equals mx plus b, slope-intercept form, by putting in 0x plus 8. Well, in this case, then, the slope is 0, and the y-intercept is at 0, 8. For number 3, that doesn't look anything like y equals mx plus b. This is what's called standard form. Where both x and y variables are on the left and the constant is by itself on the right. To get it from standard form into slope-intercept, it should usually take us 2 steps. Step number 1, subtract the x term. We're usually going to write this so our leading coefficient here is positive. Careful of the signs. This makes all the difference whether your slope of the line is positive or negative, where the y-intercept is above or below. So if I subtract 2x from both sides, the negative 4y is still negative 4y. Now, I don't want to put the x at the end here. I want to make it look like y equals mx plus b. So I'm going to put the negative 2x in front of the positive 16. Well, that looks a little bit closer, but this is still a problem. Slope-intercept form doesn't say negative 4y equals anything. It says y equals mx plus b. So now I need to do a little bit of division. I need to divide by negative 4. Then I have to simplify this. Well, negative 4 divided by negative 4 is 1. So that gives me y, exactly what we need here for slope-intercept form. Now I have to take negative 2x divided by negative 4. Put the x off to the side here for a minute and just deal with the numbers. Negative divided by negative is positive. 2 over 4 reduces down to 1/2. And then for the constant, 16 divided by negative 4, that's negative 4. So this is now slope-intercept form. It looks like y equals mx plus b. So now I should be able to just read from that equation. The slope is positive 1/2. The y-intercept is at 0, negative 4. Let's do it again. Number 4, we do the same thing. Oh, wait, hold on, these tricky people. Our leading coefficient here is negative 8x. So we're going to have to start by adding 8x to both sides. Negative 4y is equal to 8x plus 24. Again, put it in that order, y equals mx plus b. But wait, we're not finished. That doesn't say y all by itself. Again, I have to divide. So step number 1 is to inverse operation, either add or subtract the x term from both sides. Step number 2 is then going to be divide by whatever's in front of the y. Divide by that coefficient. So in this case, y is equal to, again, take the x, set that to the side, deal with the numbers. 8 divided by negative 4 is negative 2. And then 24 divided by negative 4 should be negative 6. So our slope here is negative 2. The y-intercept is at 0, negative 6. All right, what are they doing with number 5? That's just kind of weird. Don't worry about the fraction here. Let's rewrite it. Make it look like y equals mx plus b. They've written it so it's one fraction there. We can split it up into two different parts where 3 is the common denominator. How many x's are there? It's implied to be 1, so I could, again, pull that x off to the side there and write that as y equals 1/3 x plus, well, 6 divided by 3 is 2. The slope of this line is 1/3. The y-intercept is at 0, 2. Let's move on down here to example number 10. Write an equation in slope-intercept form for each line with the given information. So if we're told a line goes to the point 4, 5 and has a slope of 1/2, well, we know that the slope, m, equals 1/2, but we don't have the value for b. Now again, this is what they said earlier of we need to write the equation in slope-intercept form, and we don't have the right number for b yet. We'll substitute. We're told it goes to the point 4, 5. So I'm going to take 4 and substitute it for the x, 5, substitute it for the y, and then substitute 1/2 in place of m. So we'll have 5 is equal to 1/2 times 4 plus b. There's only one variable there. This should be fairly simple to solve for b. Half of 4 is 2. I don't want to know what 2 plus b is. I want b all by itself, so I'm going to subtract 2 from both sides. B equals 3. So my equation becomes y is equal to 1/2 x plus 3. Now that I know what my value for b is, I know what my value for m is, I can just write the equation. Example 11, the line goes through the origin, which of course is the point 0, 0. It has a slope of negative 2/3. Okay, so y is equal to negative 2/3 x, plus, all right, again, b is our y-intercept. Well, in this case, the origin, 0, 0, is our y-intercept. The value for b is 0, because, again, that's the number when x equals 0. So we'll get y is equal to negative 2/3 x plus 0. Oh, wait, hold on. If we're adding 0, nah, we really don't write it that way. Let's skip to number 13 here. Number 12 is very, very similar to what we just did. For 13, wait a minute, this is a little bit more work because they just tell us 2 points. We need to find the slope. Again, our slope formula, we're going to take the difference in the y's. So I have to take negative 4 minus 5 over the difference in the x's, negative 3 minus 0. So negative 4 minus 5, same thing as negative 4 plus negative 5. Two negatives together combine to give me a negative. 4 plus 5 is 9, so that's negative 9. Negative 3 minus 0 is, well, it's just negative 3. It didn't change. So now simplifying this, negative divided by negative is positive. 9 divided by 3 is 3. And then step 2 is then we need to find the y-intercept. If the highlighter would work. There it is. That's the y-intercept because x is 0. So our value here for b is 5. All we had to do was read it from that number. So our equation here becomes y equals 3x plus 5. Let's look at 14. Similar to 13, but oh wait, hold on. They weren't quite so nice. In number 13, they gave us the y-intercept. For 14, that's not the y-intercept. We're going to have to do a little bit of work, some substituting in that second step. Again, the first step is still find the slope. So I'm going to take 0 minus 7 over 3 minus 6. 0 minus 7 is negative 7. 3 minus 6 is negative 3. Simplify that. Positive 3/7. I can't reduce it, but I know negative divided by negative should be a positive. And now step 2, we're going to substitute into y equals mx plus b. You can use either point. I would suggest this second one's going to be easier because we have a y coordinate of 0. So again, y equals mx plus b, 0 equals 7/3 times x is 3 plus b. 0 is equal to, well, the 3's reduced down to 1 and 1. That's 7 plus b is equal to 0. B is negative 7. So the equation becomes y equals 7/3 x minus 7. If you take a look at what they have for 15 here, yeah, it really doesn't matter too much in step 2 which point you use for substituting. You have the choice. You can pick which either one you want. What I'm saying back with 14, because we had one of those coordinates was 0, the second point was easier to substitute than the first. That's not always going to be very obvious. Once we have a point in, an equation, a line here in slope-intercept form, that should make it easier to graph. Okay, so let's look at, for this one, example 1, they tell us the equation y is equal to 2x minus 3. Because of this, I know the y-intercept is at 0, negative 3. So go ahead and plot that point. Then the slope is negative 2. Now, if I want to turn that into a set of directions, I need to put that as negative 2 over 1, which means from my y-intercept, I need to go 2 spaces down in 1 space to the right. That should get me another point that's on this line. So if I go from 0, negative 3, down 2 spaces, and over 1 to the right, that should put me at the point 1, negative 5. Again, I was at -3. I went down 2 more, so the y coordinate's -5. And then I want one space to the right, so the x coordinate becomes positive. But I could also go the other way. If the slope is -2/1, it's the same exact number if we had 2/-1. Well, that would mean I need to go 2 spaces up and then 1 to the left. If I go back to my y-intercept here at 0, -3, and I go up 2 spaces and 1 to the left, look at how all 3 of those line up. So again, our y-intercept is the first point that we plot, and we should be able to use our slope as a set of directions. Go to the left, go to the right, there's the graph. Let's do it again with number 2 here. We have y is equal to 4/5 x minus 4. So that means my y-intercept is down here at 0, -4. My slope is 4/5, so that means I go 4 spaces up and 5 spaces to the right. That'll give me another point on my graph. So if I count up 1, 2, 3, 4, I'm right there on the x-axis. 1, 2, 3, 4, 5. That puts me at the point 5, 0. But with this slope, that also means I could go 4 spaces down and then 5 to the left. Because 4/5 is the same thing as -4/-5. You would reduce that, wouldn't you? So if I'm at the y-intercept here, 0, -4, and I go down 4 more spaces, and then to the left, 1, 2, 3, 4, 5, that should put me at -5, -8, and all 3 of those are on the same line. What happens when we have y equals 3? Well, again, if you think about that as y equals 0x plus 3, we had something very similar to this earlier. That means the y-intercept is at 0, 3, and our slope here is 0. So we could go through the point 2, 3. It could go through the point -6, 3. Doesn't matter what the x coordinate is, our equation tells us every single time y equals 3. If the slope is 0, this is horizontal. For number 4, we have y is equal to -1/3 x. It looks like it's missing something, doesn't it? If there's no number there, it's implied to be 0, which means this line goes through the origin. It goes to the point 0, 0. And our slope is -1/3, so that could be 1 space down and 3 to the right. So that'll put me at 3, -1. Or it means the same thing to go 1 space up, but then 3 to the left. So that puts me at -3, +1. And those 3 are all on the same line. That's where I'm going to decide to end the video this time. I know lots more examples there we could have gone through, but I just took too long talking. be prepared to come to class and start working on drawing your own graphs, and we'll talk next time.